It has been the trend of science to simplify things, to come up with shorter and simple formulas. Now the ambition is even greater. What if all aspects of reality can be understood and described in just one single and elegant formula? Welcome to Big Questions TV. My name is Arnab. Today's big question is about the theory of everything. Before we jump straight into the question, let's first quickly take a look at what this proposed theory is all about. We do have a lot of working theories in physics across all fields. Atomic physics, nuclear physics, particle physics in general, cosmology in general, and the list goes on. However, if you broadly classify the study of physics, everything falls under general relativity and quantum mechanics. That is the study of the large scale and the study of the very small scale, respectively. The theory of everything aims to combine both of these theories into one single framework. Well, it sounds so simple, but that's not the case. Scientists have been trying to figure this out for over a century with little success. The string theory and the M theory are the two major contenders of the theory of everything. To better understand, let's first take a quick look at what these two theories are. The theory of general relativity focuses mainly on gravity for understanding the universe in regions of large scale and high mass, such as planets, stars, galaxies, clusters of galaxies, etc. The force associated is the gravitational force, which is the same force that keeps you on the surface of the Earth and also responsible to keep Earth orbiting the Sun. In this theory, Einstein breaks the notion of flat space and absolute time. Space and time are no longer seen as separate dimensions, but one curved space-time. Quantum mechanics, on the other hand, focuses on three non-gravitational forces for understanding the universe in regions of small scale and low mass, such as subatomic particles, atoms, molecules, etc. These three forces are the electromagnetic force, the strong nuclear force, and the weak nuclear force. So, in theory, we have these four fundamental forces of nature. Gravitational force, described by general relativity, electromagnetic force, strong nuclear force, and the weak nuclear force, described by quantum mechanics. These four fundamental forces of nature controls every action in the universe that you can think of. Everything from the movement of the planets, to your brain activity, to tides and rainfalls, to volcanic eruption, to water evaporation, to every chemical reaction, to every thoughts in your brain, everything. Both these theories work perfectly in their domains and have been tested thoroughly at different levels. We can explain both the large scale and small scale separately, but not together. They are incompatible when we attempt to explain the regions of extremely small scale, the Planck scale, that exist inside the center of a black hole, the singularity, and the moment immediately following the Big Bang. In other words, the challenge is to understand the regions of extremely small scale and high mass at the same time. Here is how the standard model looks like, having all the four forces working together and explained in one framework. Strong nuclear force, force that binds the protons and the neutrons in the nucleus of an atom. Electromagnetism, the essence of light waves and also the force responsible for all chemical reactions. Weak nuclear force, force that is responsible for some kind of radiation. All these forces are mediated by the force-carrying particle called gauge bosons. Gravity is also theorized to be mediated by the force-carrying particle called graviton. In June 2020, more than 170 scientists across the world collaborated to complete an extraordinary complex set of calculation, which showed a significant difference between the theoretical and experimental results of muon's g-factor, which means we're at the verge of seeing a whole new physics coming up with expected discoveries of new subatomic particles or even a hidden force. Although string theory and M theory are the major contenders of the theory of everything, we still don't have a complete theory of everything that can explain all the four fundamental forces in one framework. Quantum gravity is an active area of research in pursuit of this goal. We really don't need a theory of everything at this moment until we have fully explored general relativity and quantum mechanics at its entirety. We'll probably need another Einstein to come up with a theory that can explain the anything and everything of nature in just one theory. It was a very high-level explanation in today's video. I intend to create more videos in the future with more details and insights. I need your support to help share this video as much as you can, subscribe to my channel, and always keep your mind open for big questions.